To start this project, the first thing to be done was the business process modeling notation, in our case, corresponding to the production process. We started by creating 3 different lanes. The first one corresponded to the management team, the second and the third one for each of our suppliers, for fruit and for the boxes. In the management lane we have 2 pools, one for stocks and another for the production. Since the company doesn't sell its product, the diagram starts when the stock manager makes the fruit order to our supplier, that after receiving said order, we'll prepare it and send a notification so we can go and collect the fruit. Once the fruit arrives to the warehouse, it's sent for production that will dehydrate it and mill it into a fine powder. Then, according to the amount of boxes in stock, the team will either finish production or order some boxes to one of our suppliers that will prepare the order and ship it to our warehouse. Once our product is properly packed, it's stored in the warehouse till one of the organizations come to collect it.
To make our use case diagram, we use the software Visio. This diagram shows the interactions of the system with external entities. To make the diagram, we select the forms that we want until we have the final diagram. Our actors are the stock manager, the production, the fruit supplier, tinned can supplier, and the organizations. The stock manager makes orders of fruit and boxes. Then the suppliers provide the fruit and the cans, and the stock manager generates the production orders. Then the production begins the production of powder. To finish, the organizations call for the stock manager to know if there are products to go get.
The class diagram shows the different classes and attributes of the system. It also identifies the relationships between those classes. In this class diagram, we have classes for types of box and fruit, their suppliers and their orders. We also have a class for organizations and one named final product, which connects all of the remaining classes. Apart from the production process, there's 2 classes for donations and donors. They are connected between them. Here we can see the multiplicity or the one-to-many relationships. We have one-to-one, one-to-many, and zero-to-many. For example, in the connection between donors and donations, zero-to-many means that one donor can make 0 or many donations, while a single donation can only be made by one donor. The same principle applies to the rest of the connections. For one last example, in the final product class, one product can only have one order of boxes and fruits, while each of them can provide one or many final products. The relationships between organizations and final products works exactly the same way.
And finally, we will have a demonstration of our database. This is the layout of Microsoft Access. The first table we created is the box table, with its primary key, reference, and color. On box orders, we can see the order name, status of delivery, and then box ID in box suppliers as foreign keys. In box suppliers, we will have all the information about our suppliers, their phone numbers and email, for example. On donations, we will have our ID as primary key, the donations, the method of donations, the donor ID as foreign key. This foreign key will link us to the donors table. Here we have the name of each donor, the phone number, and email. On the final product, we will have 3 foreign keys, the box order ID, the fruits order ID, and the organization's ID, linking us to these tables. On the table of fruit, we will have the reference of each fruit and then the name of each one. In fruit orders, it will be a very similar table to box orders with the status of delivery, date of order, fruit ID, and first supplier ID as foreign keys again. On fruit suppliers, we will have all the information about the suppliers of fruit. In organizations, we will have all the information about each organization that we supply for. This is linked in final product as well, as we can see each of the powdered fruit that will be assigned to the organizations. A very useful tool that was used was the query. Here we have our first query. I will show you the structure view so we can see how it was made. We choose the fields like name, phone number, donation, method of donation, and then we choose which tables we wanted to consult. We consult the donors table and the donations table. We can put even restrictions like donor number 1 and donor number 5. If we execute it, we can see the result. It will give us the phone number, the donation, and method of donation of D1 and D5, like it was asked. The query number 2 is very similar, as we can see here in the structure view. It has a restriction, in this case of mango and grapes for the fruit. On query number 3, it has a different approach, as I will show you on the SQL. The SQL language can help us make a more personalized query. As you can see here on the first line, we select the fields that we want to see, like the fruit name, the organization's name, the fruit supplier's name, the box reference, and the box color, the box supplier's name even. And then we have to select which tables come these fields, like the fruit table, the organizations, the fruit suppliers table, the box table, and the box suppliers table. We can put restrictions just like in the structure. We can choose the banana for the fruit name and the name UNICEF for the organization's name, and the green color for the box color. If I execute it, we will see the exact same table as before, with the fruit name that we chose as banana, the UNICEF name, the fruit supplier's name, the reference, and the color that we restricted as green. As you can see, these are the 5 tables that have been consulted in order to obtain the data that we indicated in each field and each criteria. We must not forget that the tables must have a direct or indirect relationship. This is an alternative way of making a possible query.